All right, in our first mini unit here, we're going to be talking about polar coordinates and polar equations. So the polar coordinate system is a little bit different than the coordinate systems you're used to, because ever since elementary school, you've been graphing on a Cartesian system or a rectangular system where you have x, y axes and you have x, y points, yada, yada. In the polar coordinate system, you have points on a plane that are determined by a distance and an angle, okay? So, and it's based on a circular system. So this might be important for surveying, or so a lot of the real world examples in the book are about boating, but you have some sort of direction and distance. So you have almost like vectors you talked about in physics. You have some angle reference, and then you have some distance reference, okay? Now on your note sheet, you have lots of vocabulary there to fill in. So we'll go through that really quickly. The reference point, because you have to be able to base everything on some sort of point. The reference point is called the pole. And the pole is just like the origin in the Cartesian system. So here is the polar coordinate system, polar coordinate plane, and the pole would be the very center in the middle. All right. And then the ray, we all know what a ray is from geometry, started at a point and then it goes on continually. So the ray from the pole in the reference direction is the polar axis. So for example, if I draw a ray out to 0 degrees, this ray would be the polar axis. Now, the distance from the pole is called the radius. That should make sense. This system is based on circular, is a circular system, so it's based on circles. So if you're talking about some distance from the pole, then you're talking about some radius. So for example, every point here has a distance from the pole of 1, so all of the radii here would be 1. And then the angle is called the polar angle. Again, that's some sort of angle. Again, it's based off of 0 degrees, just like the unit circle. So if we're looking at some angle of 45 degrees, then we start at 0 and we stop at 45. That would be your angle theta then. Okay? So there's your vocabulary. Now today, we're just going to ease ourselves into this unit. So all we're going to be doing is graphing points in the polar system. So we're using polar coordinates. So just like in elementary school or middle school, when you learned how to graph x, y points, right? You went over x, up, y, right? Just like you learned that, we're going to learn how to graph points in the polar system. Now, every point in the polar system, polar coordinates, are in this format, r theta. Okay? So for example, here's a point. I know this system is a little more congested. It's from your textbook. That's why I used the one on the previous slide for your homework tonight. And every point has r, so some distance from the pole, radius, theta. That's the form, r theta. Now theta is some angle, and we've learned angles can be in degrees or radians. So in all the polar systems that I gave you, polar planes to use to graph, they are all in degrees. You could also have radians. So if something is in radians, we need to convert it to degrees so we can use our planes that I gave you, but you might have a plane that has radians instead. Okay? So we have r, and then we have theta. So we're graphing a point with a certain distance from the pole with a certain angle starting at 0. So I'm going to skip down your note sheet to the very first example because it isn't super complicated when you have a really basic point. So we're going to graph point P, and that point is at 360. So that, again, is r theta. So we're the distance of 3 from the pole. So it's going to be somewhere on this circle labeled 3, so that all the rays of 3. And that's 60 degrees. And that is as easy as it sounds. You start at 0, you go up to 60, and then you put a point that has a radius 3. That is point P. Not a big deal. If theta happened to be negative, that's not a big deal, so I'm going to make up a new example. Point A is 3 negative 60 degrees. If we have a negative angle, we've talked about that a lot of the time, that you just go clockwise instead of going counterclockwise. So I would start at 0, and I would go negative 60 degrees. Negative 60 degrees is the same place as 300 degrees, and I would still put my point at a distance of 3 from the pole. Okay? Not a big deal. So if R is positive, you just find that angle measure and you find that distance from the pole and put the point on the polar plane. Questions about that? All right. Now I wrote this down on your note sheet for you. The trouble is when R is less than 0. Remember, R is a radius and it's supposed to be a distance, and so it's hard to have a negative distance. Every single point on the polar plane that you use, they all could be positive. There's not a negative and a positive side like there is with the x and y axes on the Cartesian plane. So, because there's a negative, this just indicates the opposite something. All right? And in this case, it indicates that your point is on the ray opposite of what you would normally make with the angle, which may or may not make a lot of sense in technical terms. So here's what that really means. I want you to go ahead and just graph the point positive 1.5, 7 pi over 6. Now the first problem is that 7 pi over 6 is in radians. We have a polar plane that's in degrees, so we need to multiply by 180 over pi. So we have 7 times 180 divided by 6, and I've done this enough today that it's 210 degrees. So if I'm graphing the point 1.5, 210 degrees, I find 210 degrees, and then I graph a point at 1.5, so that means the radius is between 1 and 2, so 1.5. That point would be Q if it was positive 1.5. Again, the problem is it says negative 1.5. So obviously that point cannot, negative 1.5 can't be in the same place as positive 1.5. That doesn't make any sense if it's on the same angle. So it yields that it's the opposite ray. So this is what I mean by that. Currently, our point is on the ray at 210 degrees. What we do is we go the opposite direction. So we're going to draw in the ray that goes through 30 degrees. It's the opposite ray from 210 degrees. And we put our point at 1.5 on that ray. So that is point Q. So the negative, you would, in your mind, graph where the positive version would be, and then you would go to the opposite ray, so you go backwards to actually place your point. Now, here's the deal with polar coordinate systems. We just graphed the point negative 1.5, 7 pi over 6. But in a Cartesian plane, when you have a point, there's only one place for that point to go. There's only one name for that point. If I gave you the point x, y, and I said, okay, graph 4, 5, then you would go over 4 and up 5. And that's the only place it could be, and that's the only way you could write it. In a polar plane, you can write these points in multiple ways. So if you just focus right here on this section of the polar plane, if I told you to name point Q, tell me what R and theta were, you wouldn't tell me negative 1.5, 7 pi over 6. You would probably tell me 1.5, because the distance is still the same, and 30 degrees. These points are at the same place. There's going to be multiple representations of the point. Remember, if you're talking about circles, we can keep adding 360 degrees and keep getting coterminal angles. So technically, I could keep adding 360 degrees, so this 30-degree angle. And so I'm going to have infinite points that are all in the similar location. They're all going to be on coterminal rays. So you have multiple representations of the same point. All right. Let's do this last example. Okay, it says negative 2, negative 135. So again, I'm going to go ahead and graph 2, negative 135, and then I'll go back and talk about the opposite. So negative 135 degrees is at the same place as 225 degrees. So go backwards. That means we're on this ray right here. Our distance is 2, so I put a point at 2 if this was positive. Now again, it happens to be negative. So we extend the opposite ray and we put our point on 2 there. So that is where R is. Again, if you focus just up here, another name for point R would be 245 degrees, because that's at 2 and 45 degrees. That's another representation of that point. So you'll have Learning Target 1 homework. I gave you 8 polar planes. You're going to do graph 8 points. And so you can do 1 point on each, so you don't have to get confused. And you'll just need to go through and graph those. If you have questions, please ask. I know the negative R, negative distance part might be a little confusing. Everything else shouldn't be so bad. So if you have a negative angle, you just go clockwise. You go backwards, just like you would with the unit circle. But if you have a negative R, you have to think about the opposite ray, right? Because you're doing the opposite of what you would have had originally. Okay?